Cool. So my name is Brenda Jin. My Twitter handle is cyberneticlove. I'm a web developer at Macy's.com where I make interactive A/B tablet web prototypes. So every couple of weeks we have a fully functional A version and B version. We put them in front of users. We do some direct observation. We get feedback, and then we refine those features. The best of the features end up going into production for a tablet-based web experience. So I'm passionate about human beings and computers, and I love working on things that improve the relationships between humans and computers, and then humans and humans. I also love connected devices, and the last couple of hackathons I won were for Internet of Things connected devices projects. So user experience, I just wanted to talk a little bit about a basic definition first. It's how a human feels about, perceives, and accomplishes an interaction with a machine. So when we talk about user experience, a lot of people immediately think interface, web interface or something like that. But there's actually a lot of machines beyond the web and computers, and a lot of machines that we interact with all the time. You can think of it as the experience of you going to a bus stop and trying to get the bus, and trying to read the machine that's giving you the information, trying to interact with that system. Maybe it's you going up to an apartment and trying to use the computer that manages the doorbell. You may or may not have a successful time with that. It could be something as basic as getting in an elevator and trying to use the computer to navigate to a floor. So I asked last night, why are we in computing? And is it because it's cool? We like to build things. We like gadgets. A lot of us are technical people. We like fresh and new things. For me, it really always comes back to my passion and love for other human beings. So an overview of this presentation, first I'm going to talk about some background tools, and then there will be an interactive section for you to try some prototyping techniques, and then we'll also do some practice testing, and I'll have some additional resources at the end. So am I talking too fast? Is this okay? Oh, okay, a little fast. I'll go a little bit slower. So, okay, you're welcome. So first of all, I wanted to go over some background tools for thinking about user experience. So user experience isn't just an artifact. It's not something that we, it's not the software that we use or the thing that we make. It's not an object. It's not necessarily physical. The physical objects, the means, and the tools are all up to you. It's really the approach that matters when it comes to user experience. So thinking about user experience is more like using a thinking tool. It's a way to critically examine the problems that we face, and then a way to arrive at some solutions that are culturally and contextually appropriate for the users. And actually, this process of thinking and critically thinking is applicable at hackathons, it's applicable wherever you work, and it's especially applicable in pitches and coming up with startup ideas. So I always like to start with the fact that humans are very diverse. So my life experience is very different from all of your life experiences. When I have a host in Italy, and I could not figure out how to open any of the windows or the shades. They don't look like anything I've ever used before. In fact, there's 3 different ways, maybe 4, to open the windows in the house. There's the electronic one, there's the one with the rope, and then there's another one with like a strap, and then there's another one with a stick that you have to loop. And then hook in. So my experience is very different from your experience. So therefore, my thinking is also very different. The interfaces that I'm used to are very different. And this is our evolutionary strength. It means that we have all kinds of ways to solve the problems that we face. But it can also mean that it's challenging to build the right product, to appeal to the right people, and to make a viable business model for a critical mass. So not only are we diverse individuals, we're also diverse throughout time. Our expectations and our habits can change. And we can learn behaviors and new habits. So to give you an example of this is yahoo.com this morning. It's what we expect of a website, right? We've got multiple types of navigation. We have some interactivity. We've got some images. very expected for today. This is yahoo.com in 1996. Now, maybe if somebody lands at a web page that looks like this today, they might think something didn't load, or maybe something's missing. It's not very interactive. But if you can remember 1996, this is probably what you were delighted to see when you went to a web page. Maybe you were just excited that you got to a web page at all. So from this point in time, or from any single point in time, it's really hard to predict what the outcome is going to be. I'll give you an example. So I used to organize these alumni events for my alma mater, and most of our alumni are over 60. And we had always had this pen and paper process of signing people in. And so we're in Silicon Valley. All the people organizing this alumni event are under 30. And we just graduated college, right? So we're excited to use technology. So we think, okay, why don't we make it electronic sign-in? Why don't we make it electronic sign up and then electronic sign in? So we do this and we make a form, and they come in at the registration and they have to fill out a web form. And we noticed that there was a huge bottleneck. There never used to be a line before, but all of a sudden it was like people couldn't get through to registration. So one gentleman was having a lot of trouble, so I went over to help him out, and he said, how do I do it? So I said, oh, you just fill out the form and then press enter and then you can go in. And he said, no, but how do I do it? And this went back and forth for a little bit because I didn't understand what he was asking. Finally, I went to the computer and I started filling in the form for him, and I saw a light bulb go off in his head because he didn't realize how to use a trackpad. It wasn't an interactive, an intuitive interface for him, and I guess he doesn't use laptops like that on a day-to-day basis. So what we thought as the organizers would be a great experience for our users turned out to be a horrible idea, and we went back to pen and paper. So this is not to say that all people over 50 don't like technology. It's just about the context of the interfaces. In fact, I think people over 50 much prefer to use an interface like a tablet. My grandmother, who's, I think she's 82, loves her tablet. She lives in America, and she uses it to communicate with people in China. And she actually needs a lot less help setting it up than she does with her PC. So as hackers and builders, we want to innovate. I hear the word disrupt a lot. We want to cause some trouble. We want to make new things, right? We want to be cool. We want to be edgy. But at the same time, we want to make an intuitive experience. We want to make sure that when our user, be it a developer, an individual consumer, another business, when they open up our product, we want it to just work. So how can these things go together? Something completely brand new and cutting edge, and something that when a user opens it just works. We want it to just work because we want to have a viable business model with human beings being the end user. So how do we do this? It really comes down to thinking about the user from the beginning of your product and the inception all the way to the end. So tool number one is identifying needs. And you can do this through interviewing and observing other human beings. So the thing you want to do is really pay attention to what is painful. And while this may sound obvious, sometimes it's not, because sometimes the pain in our lives is something that we take for granted. So has anybody, do you all know about Nest? These home devices. So I think one of the ones that's cool is the smoke detector. And do you all think a smoke detector is painful? I kind of thought it was painful, but I took it for granted that that's always how the smoke alarm was going to be. If I deep fry something, I have to open all the windows, and then I'm going to expect to wake up my neighbors at night. So what they have is you can actually wave to turn it off, and it is aware of all these different factors, and they also have a smart thermostat. So what they found is a pain point that I took for granted, but all of a sudden they can improve my quality of life. Other pain points that you can pay attention to are instances where extra information is needed. So a pain point that I can think of at the office is always the copy machine scanner. So I never know how to get my computer hooked up to it to get it to print. And then when I want it to scan, I don't know how to tell it to scan double-sided or one-sided. When I want it to make copies, it's really hard to figure out. I don't know if you have the same interfaces for your printers here, but in the United States where I live, every single office I've had has a terrible interface for our scanner copiers. So it's almost like I have to get somebody to help me figure this out or write down the instructions one by one and take it back to the scanner printer because I can't just figure it out from the interface. So for me, that's a pain point that I would love somebody to solve, and I'm sure they could solve it very elegantly. So in this part of the exercise of thinking about your product, you will articulate the problem that you're solving, because every good story has a conflict, and every good hack has a story. So you're going to want to tell the story to yourself to keep you grounded about why you're doing what you're doing. You're going to want to tell it to your colleagues to get buy-in, and you're going to want to be able to tell the story to your users. So tool number 2 is goal setting. Set some goals that are related to the needs that you've identified so that you can see the forest and the trees. You want to be able to execute on the nitty-gritty details of what you're building, but you want to keep the big picture in mind. Why is it that I came to even try to build this product? You also want to measure twice and cut once. You want to make sure that you set goals so that you're running the right tests and getting the right data to prove or disprove your theory and your hypothesis. So you can use your need-finding research against your goal and measure the efficacy of your solution. So now we have the problem and we have a goal, so why don't we just build it, right? We know now. It's hard to print things. This brings us to tool number 3, which is prototyping. A proto means first or early, right? Latin. It's a first or preliminary model of something. So it's especially useful early in the design process when you have a lot of room and possibility to make the critical changes that are going to make your product amazing or less amazing. And it's also really useful and powerful in a process called design sprints. So Google has prototyping as part of their design thinking workshops. And I always start with prototyping every time I go to a hackathon or a group programming event. So this is just a picture of one type of kind of medium resolution prototype. It's just drawn quickly in software called Balsamiq. And Linus Pauling, who is one of the founders of quantum chemistry and molecular biology, says, the best way to have a good idea is to have a lot of ideas. This one is hard because I know when I have a good idea, what I think is a good idea, I like to hold on to it and I like to keep expanding on it. I think it's kind of human nature. But if we push the envelope of our imagination, if we think, okay, that's a great idea, what's the next good idea? And what's the next good idea? And we push ourselves to think beyond that, we can actually come up with really amazing solutions that prior to that we might not have thought of. And that can be a little bit scary, but I think it's always also rewarding and fun. So, like I said, the first solution is not necessarily the best. And if you do this rapid iteration process, I think you'll like your second, third, and fourth ideas. The trick is when you do rapid iteration to not judge any of the ideas that you have. It's really a brainstorming stage. So let the idea come, write it down, and then move on to the next idea. This stage also lets you debug early when it matters most. For those of us who code, we know that we can start making a project, and then down the line we run into problems. Some of these problems, and all of the really hard ones, have to do with the fundamental design decisions that we made. Has anyone ever encountered this? That you made a design, no? Never? That you made a design decision and then later on it was really hard to fix? Yes, a couple people. Okay, a couple brave souls in the audience. I have. So this process lets you really think through what's going to happen and make some decisions before you start coding when you can prevent some of those problems. This process also lets you eventually communicate using data. So you'll be able to test your prototypes, measure, and then react to the results. So also, as you narrow down your product, it's going to be more and more difficult and more expensive to make the changes for your product. So prototyping early on and getting the results has a really high return on investment for you. So I only have 15 minutes left, so I'm going to go through really quickly some myths and truths about prototypes. Number one is that prototypes are pretty. And this is a later prototype of Google Glass, the one that's in distribution now. The truth is that prototypes don't have to be. This is a really famous picture of Isabel Olsen, the lead industrial designer for Google Glass, wearing an early version of Google Glass. And you can see that this version is meant to test something specific. It's not meant to be the beautiful product that it could one day be. I also was lucky enough to be at the Google Glass base camp in San Francisco where they had some other prototypes. I know this is small, but you can see this one's another funny looking one. These are all different prototypes, I think, of chips. That's really crazy looking. Doesn't look anything like what we see today. This one, so there's a bag, and then inside is all these electronics so that you can actually wear the thing hooked up. So I think that's pretty cool. It's also sometimes advantageous to test with the rougher sketch with your users because then they already understand that they're supposed to use their imagination. So sometimes if you put something too pretty in front of a user, they start to get frustrated with the things that don't work that you're not even testing. So another myth is that prototypes have a lot of features. This one is a pretty famous story because the truth is that prototypes can be very minimal. They're meant to be revisable and disposable. In 1996, Palm introduced the Palm Pilot. Did any of you have a Palm Pilot? Couple hands. Okay. So Jeff Hawkins, one of the inventors, actually before they made the Palm Pilot, started carrying around a block of wood, and he would take it to meetings, and he would tap on it when he wanted to do something with it, and he would just carry it around and act like it was a computer. This sounds kind of crazy, right? But you can imagine in 1996, this was before everybody had a smartphone. So before we go on this engineering journey and design this tiny computer that can actually go in your product and put all these resources into it, it's a good idea to find out whether or not you would actually use it, and if so, how and when. And then later, once you've proven that, you can ask, can I make it small enough? So final myth is that prototyping is expensive in time and money. A lot of companies that are known for prototyping, Google, AT&T Labs, they all have a really big budget. But the truth is that prototyping actually saves money. Oh, my image isn't loading. Let's see if I can. Aha. So this is a prototype of the Wii U gamepad. It was a pretty unique experience where the one user has a different screen than what everyone else sees. And first, they wanted to test whether this would even be fun, whether this could be a good model of gameplay. So they built this really quickly in a day just to see what it would be like, and it's all crazy and hooked up, and it's not anything like what the end product looked like. But it was actually inexpensive to build. Compared to the execution of the final product, and testing it is even less expensive if you find a mistake early on than if you go through the whole process of further experimentation only to find that there's a problem and you have to go back to the drawing board. So prototypes get almost none of the glory. We never hear about them. We never see them. There's a couple famous ones that I've shown you, but other than that, it's pretty hard to get your hands on a model or a picture of something that eventually became a product. But this design step actually does a lot of work. One of my favorite methods of prototyping is paper. It's a great communication tool, super cheap. You can move it around for your user. You can revise it very quickly. It's very inexpensive, and it will save you the cost of revisions later on in your product. So when you do this rough prototyping, a technique that you want to use with it is what's called the Wizard of Oz. So you're inviting your user to stretch their imagination a little bit, and because the technology to execute your vision might be expensive, you're just going to do it manually. So maybe you don't automate everything, maybe you explain something, maybe you move it, you have somebody behind the curtain moving the thing along with the user, watching them what they do and responding to it. But this will also help you just get the feedback that you need to make the decisions about your product. So I believe I have 10 more minutes, so we're going to do some rapid prototyping. Does everyone have a piece of paper and a pen? Okay, perfect. This is going to be a partner activity, so you're going to want to meet the person that you're sitting next to if you haven't already. I see a couple of you in the back who are just watching. You might want to participate. Okay. Is everybody ready? Okay. So it's your turn. You are building an email client for a smartwatch with a touch screen. So this is the window where you're writing the email. What does it look like? Oops. So I'll give you 30 seconds. You can start now. Okay, time's up. So okay, pen's down. Okay, so because we're doing rapid iteration, I'm going to have you push your imagination and come up with a second solution. So sketch a second prototype that's actually different from your first, and I'll give you another 30 seconds to do that starting now. Okay, time's up. How was that? Was it hard? Oh, no, not hard at all. Easy. All right. Look at you guys. Okay, so prototypes are questions, and questions are the currency of collaboration. So prototypes really help us discover our known unknowns. So we have questions. Will people use it? Is it the right form factor? Is the button in the right place? And then there are things like unknown unknowns that we will be very surprised to discover as we continue with the design process. So the goal of rapid prototyping is to get rapid feedback and also data based on the work that we did. And to get data, we need to test. One of the best methods of testing for this type of prototyping is direct observation. So you can put your prototype in front of somebody and ask them to accomplish a task and talk through their thoughts. So for this, you want to focus on the goal of problem solving rather than on your solution itself. Oh, I have 5 minutes. Okay. This can get pretty tricky because, as I said, it can be easy to fall in love with your own ideas, and then it can be hard to let go of some of the things that are difficult for the other user. But that's why you want to go back to the goal that you set earlier and the problem that you're trying to solve. And then, as you do this test in front of a couple of users, you'll be able to get data about whether your goal was met. Could they accomplish what your product meant to enable them to accomplish? So Harmet Esslinger, who was the founder of Frog Design, who's responsible for the Snow White design of Apple in the 1980s, says, when you prototype something and simulate, you get much better decisions for your next step. So I was going to have you pair up really quickly to show somebody your prototype and have them try to send an email by pressing on the paper. So I'll give you 1 minute to show your neighbor your prototype, assign a task, and then observe. starting now.
We need to design the send client, the
This email client, yes.
But only to read the email or to write email?
Write an email.
Write an email.
Yes.
Not only web browsing.
Okay, I see a couple of you wrapping up, so go ahead and switch if you haven't already, and the other person can have you look at their prototype. So switch. Okay, it looks like a lot of you have been able to get your user tester to look at your prototype, so thank you very much. I think that was very exciting for a lot of people. I saw some cool gestures for interaction with the device. I'm sure you all had very innovative designs. Okay, so I hope you all got to learn a little bit about this rapid design process. Of course you would do it, you know, maybe you would have a little more than 30 seconds. Maybe you could set 10 minutes aside to do as many as quickly as you can, and then pick the best ones and develop them further. And then, of course, your user testing might be more thorough. So you might pick certain types of people to bring in and ask questions to. So just a couple of additional resources for today. There's a great free online course from Stanford. It's the Human-Computer Interaction course. I highly recommend it. It's by Scott Clemmer. I'll leave these slides up at this location too if you want to get it later. There's some great software for web application prototyping in Balsamiq, which is pretty rough. Axure, which is more medium-high fidelity. They're both drag and drop applications. And then there's web frameworks like Bootstrap, and you can always use HTML and JavaScript. And my favorite, of course, is the physical materials: paper, Arduino, cardboard, clay, anything you can get your hands on. I met someone who works at Motorola creating that new modular phone. Have you heard about it? With the parts that slide in and out? So I asked her, because it's so new, I haven't seen anything like that on the market. I asked, because she's a professional prototyper, I said, what do you use to prototype? And she tells me, anything I can get my hands on. That's pretty cool, right? So it's mostly just about the style of thinking and problem solving, not about the tool itself. So if you have another couple minutes, I can take a couple questions. Go ahead.
Nowadays you get a very short time to market when you have to bring a product to the market itself. So when you start to do prototyping, when do you stop?
The question is, when do you stop prototyping? I think that's a great question. It really depends on how many features are in your product. And it depends on you. At one point you have to decide, this is the product for us, this is the core feature set, and we're going to move forward. But I think that A/B testing in production, especially if you do web stuff, is a great way to get live feedback, especially if you do the continuous delivery style at your company. So there are tests that you can run for higher fidelity prototypes and also eventually production level testing. But this presentation focused on the earlier style of testing that you can do. Any other questions?
Excuse me.
Yes.
You said that prototypes they can be not pretty.
Yeah.
But what if in this case you are testing functional properties? Okay. But what if you have to sell something that must be pretty? I mean, something that must be cute.
Okay. The question is, what if I said that they don't have to be pretty, but what if they have to be cute? So, like for a children's toy, right?
No, even something which is a wearable.
Something that is a wearable style.
Value.
Okay. So I'm building a product with my friend, and we want to make it sure that it's the right form factor because we want people to use it. And the thing with robotics and machines is that they can be a little bit scary. We want to make it approachable, right? So what we're doing is testing the software and hardware design separately from the form factor itself. So doing something closer to what Jeff Hawkins did with the block of wood, we're going to make, and I think, what's that company that does the OXO kitchen products? I've seen a lot of their physical prototypes. They do this type of physical prototyping too. You can make the physical prototypes to test the form factor or the visuals of it, the aesthetics, separate from the functionality. And I think you'll get better results because the cuteness test, sorry, the microphone, the cuteness test will not rely on the functional test. And so if there's a functional problem, you still get the data about your cuteness. Does that make sense?
Yeah.
Okay, thanks. Any other questions? Yep.
How effective is static prototyping? Meaning that very often I see people that look at a piece of paper, they say it's great, but then when you develop the actual application, you say, no, this is not what I meant.
Oh, okay. So communication is very important. The question is about the effectiveness of static prototyping. So if you're going to do a paper prototype, have the user pretend to use it like it's an application and actually have them press where they mean to press, and then you go ahead and move the paper or change it around to simulate the changing screen. But definitely don't just show them a mock and then ask them what they think. Have them go and interact with it. Yeah. Okay, one more question.
How do you handle contract negotiation with this kind of work? The way you write the contract with your customer.
The question is about writing contracts to include prototyping as part of the design process. I think you should just make it a standard that we are going to go through this brainstorming process and then help them understand that it's part of your design thinking. It's part of what makes your products amazing, and it's part of what is going to make sure that you deliver to their expectations. So it can be hard with clients with a different type of mentality. I know it definitely takes a lot of negotiations. I have a lot of friends at ad agencies who tell me that it takes a lot to get these clients on board, but I think if you keep socializing them and they keep seeing results, you'll be able to include that more and more into your contracts. Okay, can we talk after the if you all want to go, you can go, but I'll take one more question.
This one. Is there a minimum or maximum number of prototypes to achieve a good prototype phase?
Is there a minimum or maximum number of prototypes for a good prototype phase? This goes back to your question too. How much do I prototype? That depends on you and your product, and eventually at the end of the day, you have to stop the early prototyping phase and move on to a higher resolution level of testing. But you be the judge. Okay, so thank you so much for coming to my talk.